Let me just go through the PowerPoint quickly, then we'll get into it as fast as we can. So, we're coming at you from Brisbane today. I'm up here just for a very quick visit, so I'm using our office up here, and we're going to run it from this location. Now, as usual, we've got a bunch of people in the background to look at your questions, and all these are based from feedback. So the idea for this webcast came from a client visit when I was warned that if I showed a simple subdivision like intersection to the transport guys, they might kick me out. So we were looking at more complex ones, and we ended up coming up with some very interesting ones. So we'll go through that in detail. The previous sessions are downloadable, in case you weren't aware of that. We can show you where those links are later on, and we'll go from there. So in very simple format, our agenda is going to be, we look at tunnels, we look at intersections with more than one lane, and we do a little bit about dish crossings. So we're hoping that one of those topics will be of interest to everyone. So, the tunnels. Now, in traditional road design, you don't really have overhangs and roofs and that kind of stuff. This whole concept is based off changing that a little bit. So, we'll do this from scratch just to show how it works. But in principle, what you do is this. You build a standard road. So let me get my highlighter working here. I go to my felt tip pen. So what I'm highlighting here in yellow is your standard road cross section. So we can all build those. That's nothing fancy with that. We'll use generic links, and we'll add a vertical component to both edges and the center, which again isn't that complicated. They're not quite vertical, of course. They've got a very slight slope, so they're actually sloping out this direction if you exaggerate it. The reason for that is that when you build your surface model, they won't have overhangs. Then what we're going to do, I've got more slides for this to explain it, but we're going to place a marked point here and a marked point here. So let me just do it bit by bit before we get too in-depth too fast. So that's the last drawing. Let me just close that. So I'm going to do one literally from scratch. So let me go File, New. Now I won't waste time doing alignments and profiles, so I'm going to bring in my land XML file that I always use, which is this one down here. Okay, now I'm going to very quickly change the surface to a different style. And we're going to start building up a little tunnel. So I'm going to go to Home, and I'm going to insert my assembly. So create assembly. This is my typical cross section. Oh, it's going to start very simple. It'll get more interesting if we give it some time. So we go to Tool Palettes, and what we're after here are generic links. And the one we're after to begin with is link width and slope. So I press this. I want to go to the left. My value, I'll leave it at defaults of 3 meters and 2%. My code here is going to be body. So I'm calling my walls and my floor of my tunnel the body, and the rest of it the roof. I can also call it, bottom or whatever else I want. So I'm going to put that up here. Now that's the wrong slope. We'll change that in a second. I do the same thing to the right hand side. So I put that in here. Now let me just pick these and go back to my properties and just change those to negative slopes so they seem more sensible. I'm also going to rename them here. So I'm going to call this left lane. This is just good practice because it makes it easier to manage them afterwards. And my slope of -2%. Okay, so having done that, I'll do the same thing here. So I'll skip the name. I'll just make this -2. And I press OK. So that gives me my standard typical little road. Now you'll notice in the sub-assemblies there is a link vertical component here. Now it doesn't go vertical, it goes at a very small slope, and unfortunately for us that slope goes in one direction only. So the link vertical will work very well for the right hand side. For the left hand side you should use a different one, which we can show in a second. So what I'm going to do here first of all is attach a link vertical to here. So let me just zoom in. Okay, so your screen is going to be lagging a small bit here. So I'm going to attach the link vertical to here. I should give it a correct height. I'm going to leave it at the default of 3 meters. And I put one here as well in the center. Now to begin with I'll make the mistake and put the wrong one on the left hand side. So I'll put this here on the left. So what I've now got is more or less what I showed on that first screen capture on the slide. So these are going to be my 2 walls for left and right. Obviously I won't have the wall in the center of my whole tunnel, but I do need this point for the roof. So what I can do is pick my center vertical component, go to the sub-assembly properties, and I'll change the name first of all to vertical center. I'll go to my parameters, and you notice on the top there's an option called omit link. I'll change that from no to yes. So the link still exists, but it's the equivalent of having the layer frozen. So if your screens are good enough, you will see that my point is still up here, just where my mouse is holding at the moment, but the link itself won't appear. Now what I should do as well is rename these two. So I'll call this wall right, and on the parameters I'll change my link code here to body again. This will all make sense at the end when we build our surfaces, and I'll actually leave the body code out of this one because it'll cause a problem. We'll just leave it on the right hand side only. Now let me just show what happens when I do this. So I'm going to zoom back out. I'm going to build a corridor model from this. So let me just save my drawing. I'll call this Tunnel Part 1. So I'm going to go to my corridors here. I'm going to create a simple corridor. I'm going to say this is my road here. My profile I've got in the background already. And my cross section is my default assembly here. I can just press OK to everything. Now if we take this assembly, I'll take this corridor model and look at it in the object viewer. Now I'm just going to zoom in. I'll pause when I zoom in and we should see what's happening. So when your screens catch up, what you'll see is we've got basically the horizontal road with the walls each side of it and a reference point in the center line. What we now want to do is create the roof. And the way we want to set this up is that if we widen the road, the wall and the roof come with it. Otherwise it isn't much use to us. So the next step is to go back to our model here and insert the marked points. So my marked point is here on the bottom right on my assemblies. So I'll press marked point and I'm going to call the first one say TL for top left. So this should be that TL, and I'll call the other one TR for top right. It's a good idea to sketch this up on a bit of paper and write down the names as you do them, so you keep everything consistent, because that's often the biggest challenge. So we'll insert the second one here as well, marked point for top right. So TR and TR. So we come back out to here and we insert this one. So what we've now got is just literally a reference point on those two edges. So the next thing we do is press our link to marked point option. Now this is a little bit confusing because when you insert it, it doesn't show what you think it should look like on the actual conceptual view. When you model it, it's correct. So I'll just do it and you'll see what I mean. So in this case, my marked point name is going to be TL for top left, and my link code is going to be roof. So I insert this one to here, and it draws this strange line with layout mode written on it, which looks wrong, but don't worry about that. We then go and we change the marked point name to TR, and we just zoom back in here, and sorry, let me just cancel that. I'll reinsert this. So link to marked point name is TR, and the code again is roof. So I insert that here. They both show up exactly on top of each other, so it doesn't tell us much in terms of this preview. What you should do now is go to your assembly properties itself and just confirm your names are all correct. The reason for this is that when you're changing it afterwards, if your names aren't named correctly, it becomes quite confusing. So link to marked point here. This is going to, you can see the TL point. So this we should rename to roof left. This one here is a link to marked point going to the other side. So this is to the left, this is to the right. So we call it roof right. This is just good practice, and I've got a very bad habit myself of not doing this because I'm just doing kind of quick presentations. When you come back to it afterwards or you want to vary something, it does get quite confusing if you're not careful. So we've done those. Now let's just show what happens here. What I'm going to do is switch my view to an isometric like view. So I'll go down here to isometric. We'll zoom over to our model. I'll just orbit a small bit. So let me just do this panning around quickly, and I'll stop then so your computer screens can catch up. So what you should see now when your screens catch up with this is the tunnel as it was previously, with the wall left and the wall right and the reference point in the center line. When I go to my corridor model, I'll right click and rebuild it. What we see now is the roof member forming. So we've now basically got a kind of a rectangular cross section happening. Now we could have done this in a much easier way. The benefit of doing it this way is the following. I'm going to switch to 2 viewports. So we go 2 horizontal viewports here. On my top one, I'll go back to a plan view. And I'm going to do some widening. So let me just change my scale here slightly so I can see what's happening. This road is going from south to north. Okay, so I'm going to widen my right hand lane of my road. I'm going to expect my roof to come with it. So I'm going to do a polyline here. Just going to do a very crude widening. Okay, and I pick my corridor model, go to my properties, and I want to set my targets. So in parameters, I press set targets. Now this is where your naming convention pays off. I should have named this component right lane. I didn't. It's still called link width and slope, but I'll press it here. So I assume that I was pressing something with more logical names. You will see the target assignment for width. So I press the button saying none. I want to pick a polyline. I'll select from the drawing. I pick that line I've just drawn. Press enter. That's been added here, so it just shows up on our list. We do OK and OK. Now when I press OK here, what we're going to see is this. Now if you look at the isometric view on the bottom, you will see that the floor has widened out and the roof has come with it. So It's a lot easier to view when you pan it around, but I don't think your screens will be fast enough. I'll just do a small bit of it so you can get an appreciation for it. Now this will be even more visual when I put some surfaces in there. But before I do that, let me just go back to the PowerPoint, because once you understand this concept, it can be used for all kinds of things. So let's just go back in here, go to our next slide. So this second slide we had here was where we explained that we've now put a reference point here, which was called TL, and a reference point here called TR. And the last step was where we basically put the link to marked point, so one went here and one went here. Now the next slide is the one which should explain everything to us. So this is my original road, which has been widened out to here. So obviously the main component linking to that point moves with it, and the vertical component hanging off it comes with it. The marked point also comes with it. And the thing to remember is that once that marked point moves, then the second component, which is the link to marked point, will follow it. So if this diagram makes sense to you, you can apply it to everything. Really, the dish crossings is just a minor variation on this exact principle. So this is done in more detail on my blog. So I just highlighted on the bottom of the screen here where you find that. Go to our website, go to Solutions Civil, and you see the blog link in there. That's where these screen captures come from. So let's just jump back in here and change this around a little bit. So we go back to our corridor properties. We're going to build some surfaces now. So I go to my surfaces. I say I want to build a new one called the tunnel body. So I call it body. I'll change the surface style to triangulation and make it cyan colored. What I then do is pick which code to add to it. So the code I've got here is body. I add that in here. There is a button here, if you haven't done much of this before, there's a button called add as break lines. Just tick that, it's a good idea. If you don't, it will take the points and not use the orientations of the links. Now on 2010, there's a very nice feature for putting boundaries on the surface. So you go to boundaries, you right click it, and you see a button here saying corridor extends as outer boundaries. That does exactly what it says it does, so we like that. We press OK, and we see our corridor model on the bottom. Now I'm going to pick this natural surface and just change it to a style with no display, so it doesn't interfere with anything. So we'll change it to a style called blank. That disappears. Now I'll go back in here and change my view style of my bottom viewport to conceptual. So I think this will highlight a lot more graphically what's happening. Now you can't really see my top links that well. We'll build a roof surface in a second. So first of all, we can see our widened area on the bottom here has dragged the wall with it. There are links for the roof as well. So what we'll do is go back into our corridor properties and build a second surface, which we're going to call roof. And the roof, we click on the code called roof, add that in. This time I'll change my style to triangulation magenta. So our roof will be magenta colored. Add as break lines, tick that on. And again, we go to our boundaries area, right click the roof and select corridor extends as boundary. Now when I press OK, you see the roof component on the bottom. So it basically is two separate roads linked up together, a kind of a roof road and a body road. And it's quite flexible. If I go back to my first one here and drag my polyline out, I'll just zoom back out here a small bit so we see what happens. So I've got my exclamation mark showing up on my corridor in the prospector, telling me something has changed. I right click that and press rebuild, and that widens out for me. So even as a simple exercise in itself, that's got great potential before we go into the intersections at all. we can go and do volume calcs between natural surface and these models and all kinds of other bits and pieces. Now in this example as well, we've only drawn the extents of the tunnel. There's nothing stopping us hanging off second components from that, so you build the width of the actual exterior walls or whatever else you want. This was really a proof of concept, so we'll gladly listen to all feedback on how it becomes more realistic. So let me just put that drawing to one side here. I'll just minimize it, in fact. I'm going to kind of jump ahead here and start a second drawing. So what I'm going to do here is insert the same data set just to quickly get some information up on my screen. Now you will notice I'm going to do my standard boring intersection first of all and then vary it around quite a bit. So when you insert this, so I go next, just take defaults. Let me just check which one I picked. Let's go back to the standard default one here. I'll just press create intersection and it's the one we've seen more or less every webcast we've done, the standard subdivision style intersection. The important thing here, which we normally skip over, is the subassembly components. So let me just check your screens have caught up. What we've got here effectively are subassemblies, and the components I'm highlighting, the main road, they get stretched automatically to match with the various strings for the edges and bits and pieces. Now when you look at what's happening here, there's no reason that that component I'm highlighting can't be my generic link for my tunnel. So essentially all we do is replace these assemblies you're seeing now, replace those with the equivalents from the tunnel that we just did. So what I'm going to do is erase these. I'm going to erase my intersection, so I'll just do this quickly and I'll pause afterwards. And just to clarify things, I'll set my surface properties back to a 2 meter contour style as well. So I just basically undid what I previously did. I'll change my scale slightly. So your screen should now just show the standard T intersection on plan view. What I'm going to do here is do my new intersection. I'm going to press this. I'm going to go next and next. In the end, I'm going to browse to a new assembly set. So I've built the tunnel assembly set already. I showed some of you guys this last week or 2 weeks ago. I press my button and create. So what the software builds here now is the exact same thing we just showed, only it's the two tunnels meeting. So if I go and let's do the two viewports again. So we'll do two horizontal. So I'll go to my top viewport and pick a more interesting perspective. So what I should have done a while ago was set the surface to a no display style. So I'll just very quickly do that now. So I'll make this blank and press OK. So we're seeing the tunnel, same as we had previously. Just to highlight how this works, I'm going to build my body surface again. So I go to my surfaces, exact same procedure, make a new one, call it body. I'll make my style my cyan triangulation again, and I'll add my body component to this. You will notice here, I'll just pause for a second, I have added extra codes. We can build wall left or roof right or lane left or right. So as you're building these sub-assemblies, you just think about the various scenarios that you might have to kind of cater for in future and just try to incorporate them. So we go to our body, we add that, go to boundaries, and once again add the corridor extents as the outer boundary. So it shows up here as corridor shrink wrap, which is exactly what we're after. So we press OK, and I'll once again set my views here to a conceptual style. So what we're seeing here is the same thing. Let me just save this drawing because my machine has been acting up quite a bit. Tunnel part 2. Okay, now what we're seeing on the top viewport is what we had previously, only there's two tunnels intersecting. Now this is obviously a very simplified case. There's nothing stopping us doing the same things that we normally do. So on my bottom viewport here, I'm widening my left hand side. I'm picking my curve return and I'm going to make it a much bigger radius. I'm going to, on my other side here, I'm going to click this curve return and I'm going to add a widening to it. Sorry, I press my plus button here. So I've now done, in road design terms, it's like a bus slip lane. And again, I'll drag my taper angle around here somewhere. So the geometry is pretty ugly, but the point here is that I can now go and stretch all these components, go to my intersection item on my left hand side here, obviously got an exclamation mark. When I right click that and select update regions rebuild corridor, it gives me the usual warning. And my my intersection updates for me. I then right click and rebuild the corridor, and on your top viewport now you will see my tunnel has stretched out. So the example I showed initially of the kind of the filter lane, that's just the exact same process as this, but I've paid more attention to my geometry. I've kept my angles realistic and that kind of stuff. The principle is that we've taken the simple road sub-assemblies and given them a roof in very, very kind of vague terms. And we can then go with that and build all the volumes and surfaces. Now we've had some very interesting feedback. One guy in West Australia says that he's interested in doing trenches. So trenches to house pipes, and that they're always crossing over, so he wants to use this as a means of building those with the actual intersections, which sounds like a perfect way to do it. On the blog, these guys in the US have mentioned that they see it as a very useful tool for mining, which is obvious when you look at it. It actually hadn't occurred to me when I was initially doing it, but it can be used there as well. So we like this one a lot. We'll just close this drawing. I'll come back to it in a while. I'll save that. And I'll just go up here and close this one as well. Now, so that's our tunnel concept. There's a lot more to say about it. We'll be interested in all feedback. We'll come back to that feedback stuff later. Multiple lane intersections. So we always do show two single lane roads meeting. Everyone asks us, what if you're doing a more complex road? But this is a kind of a highway example. It doesn't have to be a highway. It can be just a bigger road with dual carriageway and medians and that kind of stuff. And the question is, how do you tackle those? So let's just go back in here and show two examples first of all. The first one I'm going to show here is, I showed this briefly last week. This is actually the screen capture that I just showed in the PowerPoint. So this is a civil drawing, and in this case we've done a kind of a simulation of how you would model an overpass. So the lanes that I'm highlighting now are our main road. We've got the slip road coming off to the left hand side as you travel north, which I'm just showing here, and we're given the options to go straight or turn left or right to exit or go over the bridge. Now, the way all this works is the way you'd expect it to work. So we go to our view and we go to a single viewport. So I'll select this one here. Now when I move this around, you can see my curve returns traveling along the road. If I pick my main road here and start dragging that around, you will see the slip lane curve returns moving as well. The whole thing works as it should work, but it's obviously just it's been done already. So let's just go and show how that works. So I'll put this drawing to one side. I'm going to go and I have to start a new drawing very quickly. I should have kept the previous one open. Now, one thing to show here before we go any further is that, let me pick I think it's this drawing here. So in 2D, okay. In 2D it's pretty obvious. You build the strings and you go from there. I'm just going to restart my AutoCAD here because my memory isn't working too well. So in 2D, it's easy. You build your strings and drag them around the place. When it comes to modeling, how are you going to model those multiple lanes together automatically? That's the question I want to address here. So the drawing file I'll open when I get this done will explain some of this. So let me just reopen my Civil. So essentially, the way I explain it, that we do what we want to call partial intersections, which is what I have in the PowerPoint here. So we build a half road. Let me just go back into my PowerPoint. So my intersection set will be, for example, let me pick a different color for my highlighter so I can see this properly. So let's click on the felt tip pen. So go to my pointer, felt tip pen, here we go. Okay, so what I'm going to show is that we model the area I'm drawing here. So the intersection model will be just that component. We build a separate one of this component. Okay, my mouse drawing isn't too accurate here because I can't really control it too well. But the idea is that we build a bunch of small intersections which all come together to form a big intersection. And this seems to work quite well from the experiments with it. So let me just show the concept here. So I'm going to open, pick sample multi here. So what I've done in this case is the same little data set that I use for quick purposes, but this intersection is only modeling half the road. So it's modeling my center line to my edge of bitumen. Now I'm going to show how that is not center line, how it's going to be my last lane or whatever you want it to be. But it's not modeling the opposite side. So I could have here, take this assignment, do more offsets. So I'm just going to erase this one in this case. But I can have a bunch more lanes here, which are standard models, and just have this side of it taken care of with my automatic sections. Now, just to show how you build this, it's actually really easy. I'm just going to erase it and redo it very quickly. So I'm going to remove these offsets as well. I'll also remove these, which is the important bit. So once again, I'll do my usual default assembly set. So I'm going to go next, next. I'll go to my browse button. I'll go back from my tunnel to my standard options that come with the software. This builds our usual simplified intersection model. Now, what I'm going to do here is zoom over to these. So these are the typical cross sections that make up the logic of the system. So on my primary road, I don't want my right hand lane here, and I don't want my right hand stuff here. The last one here is my primary road full section here. I don't want to model anything. I'll do it on a separate little corridor model. So I just basically butchered up these. Now I should rename them as well, which we'll come back to in a second. I'm going to zoom back to my corridor model here. I'm going to go to the corridor itself. I'm going to right click and rebuild it. What we see here is half the intersection being modeled. And the idea is that this is currently the center line, but it wouldn't be the center line. It would be my second last string. So I model just that final output section. I can now go stretch it and move it all around the place and do what I had previously. So the part which I should have mentioned earlier, which I forgot, was this. On that wizard, which I always run through very quickly, there's one very important button. So go next and next. This section here, as I highlight these various components, you will see on the bottom of the screen it tells me which cross section it's looking at. So you would go insert defaults, edit them, and if you look over here you'll see a button called save as a set. So let's just say I had done all these, I had renamed them. I can click on here and browse to an existing one in my drawing. I will then save as a set, and I've saved one here called partial. So you do it once, add it to your pool, and then bring them together to build a bigger road. So let's just put that one to one side again. Actually, I'll leave that one open here. Now, to run this in a more realistic simulation, you would draw a center line here. You would go to alignments, from objects, do a second one here, go to alignments, create from objects again. Now I'm going to do something a bit different here. I'm going to pick my secondary road. I'm going to do some offsets first of all. So I'm going to offset it, say just to the left and the right. So this is going to be, let's say we got a dual carriageway. This is my first lane. We're going to model the second lane with the intersections. So let's just exaggerate the width so this is very obvious what's happening. I go back to my intersection wizard here. Now the part that you might not have realized is that you can create intersections from the offsets as well. So my main road is my dark blue one here. Now in this case we've got no surface model over or alignments, so we just do 2D only. We'll go in here, offset right, we're happy with everything. We don't create the corridor because we can't, we've got no vertical design. We press the intersection button and it makes this. I simply erase the bits I don't want. Let's just go in here, I erase these various alignments. And what I've now got is the kind of skeleton of a more complex intersection. So I can press this here, I can pick my curb returns, make them far wider. So this, let's just press the second offset here. So this setup, we've got our outer extents, which is the line I just highlighted. We've got our center line of our carriageway and our main center line. And if I press these and drag these out, I can now go to this outer extents one here, add a separate widening component, so I can make my acceleration and deceleration lanes. I can also go to my curb returns themselves. When you press those, you'll see curb return parameters. There's nothing stopping you going in here, and it just warns me that I've erased some of these. Going in here and changing it from a single circular fillet to a three-centered arc. So you can build up a realistic looking curb return for yourself. I won't bother doing that now, that's just a matter of typing in the numbers. What I will do is select this and do some offsets on it. Before I do that, let's just say that this was all we needed to do. This is like a multi-lane intersection on plan view. Obviously you don't want this ugly line here tapering in and out across your line. So you select that, you go to your alignment properties, and you'll see a tab here called masking. So masking is going to do what you expect it to do. You press the masking, just figure out which direction we're moving in here. So it's going north to south. So I'll say mask that one from here to here. I'll press OK, and you will see that's being masked for me. So you will continue and do that for the others as well. So on this one, same procedure, alignment properties, masking, go from here to here, etc., etc. So we've now built a slightly more complex road. That can be taken as far as you want, really. It's just a matter of basically putting the logic together so you know which string depends on which other string. I want to highlight one thing here before you get into trying this kind of stuff. Again, we leave it on 2D views only, just to get the concepts across first of all. I make an alignment here. Now when I do my initial offset, so I go to my offset alignment here, you do have the option to do more than one offset on each side. So I'm going to do 2 to the left and 1 to the right. I'll go even increments of 10 meters just to show what happens here. So it builds me these. So obviously 2 to the left, 1 to the right. Now I'll widen these some more just to really distinguish them. And I want to emphasize something here. If I press my inner alignment and do a separate widening component on it, I can do all this and my outer alignment is not being affected. So just played around with that one. It's had no effect on my outer offset. That's because each of these is a function of my center line. Now I'll do a variation on that. I'll just move this one out to here. So I'm on my other side. I select my offset and I'll offset that. Now I'll offset it to the left and not to the right. So I'll go 0 to the right, 1 to the left, give that say 9 meters. Press OK. So it looks as if I've achieved a very similar thing, but there's one very subtle difference. If I press my outer alignment here and add the offset, you will see that my inner offset comes with it completely. So there are cases where you will need each of those scenarios, and it's just a question of thinking before you start on which one you want to achieve. So if you go back to this one here, this alignment here which I'm highlighting is a function, this alignment here which governs my curb return, that is an offset from my edge of bitumen alignment. So when I drag that here, these ones come together. If I had done it the other way, so that scenario represents this scenario here. Now if I had done it the other way, when I move this, it wouldn't work properly. So as long as you get your head around this logic, there's nothing stopping you from building up a far more complex intersection just using the same kind of simple intersection functionalities. Now to apply that into the vertical, there is one subtle trick. So I think we'll end up doing more webcasts on this in the future, but let me just go here and open up a drawing. So what I've got here is my offset parameters. Press OK. Now in this case, I've done my, I'm using my simple data set just for speed. I've done my offset. What I've also done here is sampled and designed a vertical on that. If you go and try to build your corridor model and you haven't picked a vertical design for this edge of bitumen, or whatever you want to call it, it'll obviously not build a corridor model for you. That should be okay, and you should be able to build a corridor easy afterwards. It can be a bit tricky. I think you're better off to do this. So in this case, what I've done is I've pressed that one and I've gone to surface profile on the top and I've clicked on my natural surface and done my design as well. So that's all been covered in the past. I won't go through it now. What I want to show is this. I build my intersection here, and that's my main road, my red road here. I go next and next. I should browse to my partial one. I'll leave it as the default. So I would now go and start butchering up my sub-assemblies to remove half the road like I showed previously. Now, okay, I won't do that just now, but most people I know want to work on the 2D geometry first and then put in the verticals afterwards. What I'm suggesting here is that you do both together. And so first of all, leave the software, chuck in the defaults, go to your corridor model on my left hand side here, go to my properties, go to the parameters. These are all the regions the software creates. I'll just turn all these off. Press OK. So my corridor model still exists. I can now go and start doing all my work to get my horizontal geometry worked out. The software isn't calculating the corridor. It'll work nice and fast. And when you're done with that, you go back to your corridor model, go to the properties, and turn everything back on. Press OK. You go to your intersection model. There's two steps. There's the intersection component as well. You right click that and you press update and press continue, and the whole thing works afterwards. Obviously my design here makes no sense. I'm just dragging things everywhere. But the point is that I think it's a good idea to leave the software, insert a default intersection, switch it off do all your editing and put it back on afterwards. So we'll get some feedback on how much more information you want on this stuff, but I see huge potential in this. Now, we're just getting towards the end of the session here, so let me just check. The last one was the dish crossings. Now, since I started doing this stuff, people are always telling me that even on simple intersections, you want to chuck in a dish crossing where the roads meet, so that water gets trapped and drained away. So essentially, the procedure for doing this is a small variation on the tunnels procedure. What I'll do is I'll show you the finished drawing. So I go to my dish crossing here. Now I haven't paid a huge amount of attention to the actual dimensions of my dish crossing. I'm just showing the kind of concept of it. But if we go to our orbit view here, so your screens might lag slightly. I spin this around, and if you look in here, you will see my dish crossing has been inserted. Now this is actually more tricky than you might imagine, because you design the inside string here, which I've just highlighted on my top viewport, and you must come back out to your outside string. So essentially what you do, on your assembly here, there is an invisible generic link. So I'll do some graphics of this sometime just to show how it works, but I'll just do an AutoCAD sketch here of what happens. So this is my center of my typical cross section, my assembly. I do my generic link, which is my default design. I make that invisible. So let me just change it to a different line type to simulate that. So go to my line type here and make it dotted. Okay, so we got these dots showing up. I do my dish crossing, which comes from here, back to here, back to here. I also put a marked point back on my center line. I then do my link to marked point, which comes from this point back to my center line here. So essentially, the software designs the road to the edge of bitumen and chucks in the V-drain afterwards. So you still get your same crossfall, and you build your dish crossing. You would obviously put in your curb and gutter here and work across from that side. So we can do more on the dish crossings. It isn't quite finished yet. In some ways, it's actually more difficult than the tunnels, believe it or not, because you have to take in the road crossfall when you're doing your V's. The tunnels, once you understand the concept, are quite a simple thing. So we just come to the end of it here. So let me just go to my last slide and do a quick wrap up. So we're going to ask for some feedback on this one because we see a lot of information on it. I won't do polls now, but we will do an email out to attendees to get some ideas for what this stuff represents. So at this stage, I'll wrap this one up, and we'll do a mail out to everyone who attended and ask them for feedback on what we should do more of. Cloverleaf is one mentioned, and we'll think about some more afterwards. So with that, thank you again for your attention, and we'll see you soon.